Hello guys, in this video we'll look at how to derive relative displacement equation. Okay, so look at this scenario here. Okay. Now there are two particles here, particle P and particle Q, and there are three locations O, B and A. These three locations are fixed, right? So particle P and particle Q can be moving towards each other or away from each other or in the same direction. But at a particular time, P will be situated at B and Q will be situated at A. And point O is a reference point that we're gonna take O as a reference point, and we're gonna define that anything to the right, any displacement to the right is positive, any displacement to the left is negative. This is a convention, right? So like we learned it in the previous video, and we can represent the displacement of Q being the particle, displacement of Q particle with respect to O. Displacement of Q with respect to O would be the vector from O to A. So I can represent it with this symbol, this notation, OA, and there will be an arrow on top. The displacement of P with respect to O can be represented by a vector going from O to B and can be represented by symbolically OB, and there's an arrowhead on top. So it says that it goes from O to B, right? So likewise, we can define displacement of O with respect to Q. O with respect to Q can be represented by AO, A to O. And displacement of O with respect to P can be represented by B to O. These are all vectors. This is a pretty name that is given to the vector so we can identify. Now, if you want to calculate how far away Q is from P, or what is the displacement of Q with reference to point P. So if you're standing here, you will know how far Q is away from you. So that can be written as displacement of Q with respect to P. Displacement of Q with respect to P, this can be represented by a vector going from B to A. B, A. Now they are all vectors. Now since they are vectors, they should obey additional law of vectors. So how can I get BA vector? BA vector can be obtained by, first you go from B to O, O being the reference point. Think of these as position vectors, then it is easy for you. B to O, then O to A, right? So what is BA? BA is given by this pretty symbol here, SQP. SQP. What is BO? You have OB, which is displacement of P with respect to O, and BO is defined as displacement of O with respect to P. So just for the sake of representation here, simple representation, I'm gonna write OA first, then I'm gonna write BO. So OA plus BO. Right. So what is this? OA is displacement of Q with respect to O. What is BO? BO is displacement of O with respect to P. Right. So we have obtained a beautiful equation. So we call this equation of relative displacement, and I'm going to write it as this: displacement Q with respect to P is equal to displacement of Q with respect to P. So these could be any two letters or any two particles. First you start with Q. What is on the left side? Q with respect to a certain point. This could be O, or this could be A, or any other point in space, or it could be Earth, right? Because we are all living on Earth, so Earth could be a good reference point. O plus then displacement of this first and this second. So this is called equation of relative displacement. So let me write it here. So equation of relative displacement. This is the equation of relative displacement. So it doesn't look all new because we just wrote the addition of two vectors, which is equal to a resultant vector. So this is all vectors. So this is actually this is similar to position vectors, dealing with position vectors. So we don't deal with this equation much. We are going to deal with equations of relative velocity and equation of relative acceleration. We don't deal with this much because this is basically addition of vectors, but we're going to use this relationship to obtain or derive the rest of the equations. So thank you for watching. I will see you guys in the next video. Thanks.